All right, so now we're going to talk into about, now that we've done like the parent function ones, right? And remember I left these up here to kind of look at them. So we're going to talk about transformations. Now, the good thing is a lot of this stuff is all the same thing that you guys remember from transformations before, right? So let's take a look at this one for a second, okay? I just use sine because I just did. It doesn't matter. Whether it's sine, cosine, same thing. It's all the same, right? But again, what I want you guys to think about for now is the basic transformations of graphs that you did in Algebra 2, you did in Algebra 1, we did in the beginning of the year, right? When you have a number out front here, what is that? What does that do, right? It makes your graph, it's the vertical stretch and shrink, right? This is the same thing. We're just gonna give it a name and call it an amplitude, right? And that's your A. It's the vertical stretch and shrink, right? Just remember what happens if that value is negative, right? That means it gets flipped. So just remember that, if negative, flip, okay? So that's important, again, to talk about. Now, we didn't do this. You guys did it a little bit last year in Algebra 2. Do you remember think of this as like the X, right? When it's inside the parentheses and it's being multiplied by the X. Do you guys remember at all what that does? Well, it's like that's a horizontal stretch and shrink, right? And that's going to be that value of K. Okay, so for right now, that's a really important value because think about it, if it's going to horizontally shrink, right, that means that the period is going to change because now it's going to take less time to complete that cycle. Good news is you don't have to worry about that yet, okay? But I want to get in the habit of identifying what that K is and going through the whole process. It's going to be 1 for now, but I want to go through that process because you guys need to know it when we start doing it for real and when we start adding it in later, okay? So it'll be there. Now, if you guys remember, when you have something inside the function that's being added or subtracted to X, what kind of shift is that? Well, it's the horizontal one, right? They call it, for this, we're going to call it a phase shift. Okay, and that's always going to be, actually, wait a second. Let's get rid of this. Where'd they go? They're there. Okay. One other thing that we need to talk about with these, I'm going to get rid of this too, is, all right, one of the other things that we need to do is, we talked about what this K does, and it's always going to change that period, right? So your period is going to be 2 pi divided by K. All right. Again, our K is always going to be 1, so our period is always going to be 2 pi for now. But again, I want you guys to see it, want you to know it, so when we start doing it later, makes it easy. Okay. The other thing that we need to worry about is our increments. That's what you go by, like that's how you count on the x-axis. Like we were going by pi over 2, pi, 3 pi over 2, 2 pi, right? So when it's 2 pi. So how to get that, you just take your 2 pi, whatever your period is. Actually, that's right, period. You're going to take whatever your period is and divide it by 4. Okay? Again, we'll talk more, this will make a lot more sense as we start doing examples, but they're really important steps that you always need to write down. All right, so let's get back to what I was talking about before with the phase shift, right? They call it a phase shift in here instead of like a horizontal shift or like a left and right shift. Why? I don't know. They just like to use different words, but it's the same deal. Okay, and just remember, it's always the opposite of what's in here. So whatever that PS is, okay, I'm just going to use PS for phase shift instead of another different letter because it just makes more sense, right? So whatever that thing is in there, that's how it's going to move. And then what's this on the outside? When you have something that's added or subtracted on the outside, what does that mean? Right, that's your vertical shift. That's how it's going to move up and down. sine, that's cosine. We're gonna leave those there too. Okay, so what we are gonna do now, let's just go through a couple basic graphs, couple changes, and let's see what's gonna happen. All right, so first one. Okay, so again, notice, what do we have, right? We got a +1 there. What's that gonna do? Well, it's gonna be our vertical shift. It's gonna shift the whole thing up, okay? So, one thing that you guys need to get really good at is identifying all of this information. You're gonna write it down for every problem, right? So, your A, or your amplitude, in our case, what's out front? It's just a 1, right? What's our K? That's a number being multiplied by theta. It's just 1. Our period is going to be 2 pi divided by k, which is just 1, so it's 2 pi. Our increments are going to be, you're going to take your period, which is 2 pi, and you're going to divide it by 4. And that's going to reduce to pi over 2. Which makes sense, because that's, if you remember when we were counting everything, it went by pi over 2, pi, 3 pi over 2, 2 pi, right? Why are we dividing by 4? Because of the 4 quadrants, right? You're dividing in 4s. Okay. Our phase shift. Don't got one. Vertical shift. We're going up 1. You can put +1, up 1, doesn't really matter. All right. So when to graph it. Okay, don't forget, if you guys didn't see the post, I put graph paper as a PDF file in the stream of the Google Classroom. So that way, if you guys want to, if you didn't yet and you want to print that out, might make it easier than trying to handwrite your whole thing in here. It's definitely easier, but you gotta print it out. Okay, so where do we start? Well, we gotta label our axes, right? Use your increments, right? You're going by pi over 2 every time. So 1 pi over 2, 2 pi over 2 is a whole, 3 pi over 2, 4 pi over 2 is 2 pi. Okay, and don't forget about to go the negative direction as well. Negatives are easy. You just take whatever you have here and make them negative. Okay, and then you really should label these too. Okay, now, here's where it's super important that you guys remember this, okay? So, start in the middle. At 0, oops, I don't want to make that there. At 0, we're doing sine, right? So at 0, what is sine? Sine at 0 is 0, but because we have a shift of up 1, 0 plus 1 is 1. Right? At pi over 2, it's 1 plus 1 is 2. At pi, it's 0 plus 1 is 1. At 3 pi over 2, it's negative 1 plus 1 is 0. And at 2 pi, your 0 plus your 1 is 1. Okay, and then there you go. Okay, look, notice it has that same exact shape as the original sine, the parent function that we looked at, and it should. Okay, and then don't forget about, you always have to go in the negative direction, right? I would just follow the same pattern, right? Look at what you got here. You're going 1, 0, 1, 2, 1, 0, 1, 2, and then back to 1. All right, and there you go. Okay, and that's all it takes. So remember, it's super important to make sure you remember you got y equal about these. All right, let's take a look at what's going to happen if we do something else besides a vertical shift. Okay, what if we do that? Okay, that's y equals 2 cosine theta. Okay, well, what's our amplitude this time? Do we have one? It's 2. K is 1. Again, this is going to get a little old that I keep making you guys do this for now, but we need it. Okay, remember, period is always 2 pi divided by k. Your increments, you're taking your period and dividing by 4. Phase shift, don't have one. Vertical shift, we don't have one. Okay, so again, all this is staying exactly the same because our period didn't change. Again, it will later, which is why it's going to be a little bit annoying at first that I keep going through like the k and the period and the increments. But again, it's a habit that I need you guys to get into. All right, so now we're doing cosine, right? So concentrate on these, the ones, the zeros, the negative one, the 0, the 1, okay? So what happens? Well, what is cosine at the start? At 0, what is cosine? Well, it's 1, right? But now we're taking that and we have an amplitude. It's a multiplier, so we multiply it by 2. So 1 times 2 is 2. Okay, at pi over 2, it's 0 times 2 is still 0. At pi, it's negative 1 times 2. It's negative 2. 3 pi over 2, right? 0 times 2 is 0. And at 2 pi, you're coming all the way back around again. It's 1 times 2 is 2. Okay? Now, some people always have an issue with like doing the negative graph. Okay? You are not simply taking this and reflecting it over. That's not going to work. No, actually it will in this case, but it's not always going to work. You don't want to just reflect it over. Okay? What you want to do is follow your pattern, right? Now you're working backwards, so work from left to right. I'm sorry, from right to left. So this one, we already have that point, that's the start, right? Remember that's 0 or 2 pi. So as you're moving left, what's the next number you want to use? The 0. Well, times 2 is still 0. We move left one more to negative 1 times 2 is negative 2. We move left one more to 0 times 2 is still 0. Move left again to 1 times 2 is 2. And there's our graph. Okay? It should be a wave that follows the same pattern. If at any point it's not like looking like one continuous wave, you screwed up somewhere. You shouldn't have, and remember, your period is the amount of time it takes to get back to the start. Okay, so if you don't have, like at 0 and at 2 pi, wherever you start and wherever you finish, if they're not the same number, then you screwed up somewhere. Okay, so you're gonna go back and check that. All right, at this point, okay, I'm gonna kind of stop this. And then I'm gonna do one more example with kind of where you have two things, and then I'm gonna have you guys try some. All right, so let's do one more. You're probably at some point gonna need to just pause this, maybe rewind it, go back a little bit, see what's going on, okay? That's kind of the nice part about this is you guys can rewind. You can't rewind me as much as you might want to in the classroom, but you can here, which is kind of nice. So you can go back and watch that over again. Maybe you missed something. Take it at your own pace, okay? All right. Okay, so now I'm mixed in two. Okay, there's an amplitude and there's a vertical shift. Okay, so let's talk about how that all works. Okay, again, amplitude is the number in front, that's 1/2. K is still just 1. Period is going to be 2 pi divided by K. which is 2 pi. Sorry about the screeching. Increments is going to be 2 pi, whatever your period is, and you're going to divide it by 4. Okay, phase shift. We don't have one. You're not going to have one for a while, but again, I need you guys to see it and look at it. Vertical shift is down 1. Okay, or minus 1, however you want to say it. Okay, let's clean this up. There are a bunch of different ways to graph this stuff. Okay, I find that this is the way that makes the most sense to people. It is, especially when you start adding in more complicated things, it just makes a lot more sense to do it this way. Like when you have a phase shift and a vertical shift and a period change and an amplitude all in the same thing, if you can follow it this way, it makes sense. Some of you guys may want to look like, if it was just a phase shift or if it's just a vertical shift, you may want to take these and just go, oh, I'm going to shift it all up one. You can do that, right? But sometimes when you combine them all in, it's a little bit easier to do it the way that I'm showing you. So that's why we're doing it. Okay, so now that we've got all this, this is all still filled out from before. Here's where you need to get a little bit careful with these, okay? Our amplitude is 1/2. So you can always adjust your y values, right? If your amplitude is really big, maybe you want to skip. Like if your amplitude is 6, maybe you want to go 2, 4, 6. If your amplitude, you can change this and make it whatever you want based on whatever your amplitude is, okay? So because that's a 1/2, all right, I'm going to adjust this and make it a 1 there. Now, you don't have to. I'm going to do it only because when I start plotting, if I was to do -1/2 and I start plotting, it's going to start overlapping with and it's going to be like right in between where I already wrote all this stuff, and it's going to look messy. So, especially when you get fractions, maybe you want to expand this up a little bit and go like every 2 spaces is a 1. Again, up to you, okay? All right. Okay, so where do we start from? Well, we don't have a phase shift, which would move it left and right, so we're going to start right here in the middle, okay? And we're doing a sign value. So again, we're following this pattern of 0, 1, 0, -1, 0, okay? So at the start of our pattern, okay, right here, which is at 0 now, sign value is 0, okay? Now, when you have multiple things, think of it like a regular old equation, right? You're just substituting into this. This becomes, right, when you're at 0 or at the start, sine of 0 is 0. So you're going to take this sine theta and replace it with the 0, and it's really just 1/2 times 0 minus 1, which would be -1. So at 0, you're at -1. Okay? At pi over 2, you're at 1, so it's 1/2 times 1 minus 1, which would give you a -1/2. Okay, at pi, you got 1/2 times what? 0. Minus 1 is -1, so we're coming back. 3 pi over 2. What do we got? -1. So it's 1/2 times -1 minus 1, which would be -1.5. Okay, so that's going to be down here. And at 2 pi, again, we're back to 0. So it's 1/2 times 0 minus 1 will give you -1. Okay, and there you go. Remember, the graph should always have that shape. Okay, if you've got an amplitude, it's obviously going to be like way stretched out a little bit or it's condensed, but for the most part, it's always going to have this wavy shape. So if you don't have that wavy shape, you're screwed up and you got to go back and look at it. Okay. Don't forget, we always want to graph over 2 periods, so follow your pattern, right? We're just repeating. Since we're going left to right, I'm going to start here, right? What did we do? Well, this was at -1. Then the next one over was at -1.5. Then -1 again. then 1/2, then -1 again. Okay? Follow the pattern of what you already did and just repeat it over here. Okay? If that doesn't work, then go back and do this again. Right? This is 0, right? Or 2 pi. Then you're moving backwards. -pi/2, -pi, -3pi/2, -2 pi. Okay? All right. So, like I said, if you guys have questions, again, rewind it, pause it, go back, see what you got. Okay? I have another post of 2. I'm going to put it up there. You guys should see it, of 2 equations that I want you guys to try on your own. You'll see a video underneath for each one of me graphing it out and doing the whole thing, but try them on your own first. Come back, see how it goes. All right? So try those out. Let's see what happens.